Everybody, thanks so much for joining our first AEG online member call, and I'm delighted to introduce Dr. Jamie Stephen. He's the Managing Director of TorchLight, a bioenergy strategy advisor and project developer, working with governments, utilities, large industrial emitters, the transportation sector, property owners, and investment funds. Projects range from the development of energy facilities to the national industrial strategies. Jamie has over 2 decades of experience in the bioenergy and carbon management industry, working at the interface of the energy, forestry, agriculture, and waste sectors. He holds a PhD in forest and energy economics and a master's in chemical and biological engineering from the University of British Columbia. Site is leading development of Canada's first BECCS project, Rocky Mountain Carbon at Hinton Pulp. Amy, thank you so much for joining us today.
Thank you so much, and thank you to the AEG for the invitation. I'm actually in Dominican Republic, so I apologize if there's any background noise. The in-suite Wi-Fi is a little bit to be desired, so apologies for that. So today I'm going to I'll just bring up my deck here. I'm going to talk about a specific part of how forestry and energy can come together. Basically, it's something called BECCS, so BECCS, and what it is a combination of carbon capture and storage, which many of on the line will know about, with bioenergy. The key thing about this is it actually is a way to enable greater energy exports from Alberta, but actually become the lowest carbon supplier in the world. And I'm going to explain how that is possible. Many of you will know that Alberta oil has a higher carbon intensity than some of the others out there, higher, in some cases, higher carbon intensity for LNG, but this is a method to actually outcompete the rest of the world. So as a basis, just where we can get started is when we talk about climate action and how to achieve certain goals that have been established by governments, how to be leaders, it's important to recognize that it's called net for a reason. So when we talk about a business, there's one way to increase income is to cut costs. And that's largely what we've been doing. But the other is to increase revenue. And so there's two sides to any carbon equation. One is to avoid greenhouse gas emissions, and that means, largely switching away from fossil fuels. But the other side, and the one that I would argue is more important for Canada, is actually where we are can be the world's leader, is the negative emissions. And you say, well, how do we get to negative emissions? And that's what I'm going to talk to you about today. So in those negative emissions can essentially eliminate the emissions that do occur from fossil fuel combustion. So what is BECCS? What is bioenergy with carbon capture and storage? Basically, it's three things put together. One is atmospheric carbon removal. We have an amazing technology. We have a lot of it in Canada. It's called a tree. Right? And, we actually have the world's third largest forest. And in Canada, 94% of forests are publicly owned. The second is bioenergy. And in most countries, there's only a couple exceptions. Canada is one of them, is that bioenergy is the largest source of renewable energy by far. It is 60% of the renewable energy in the EU. It's about 50% of the renewable energy in the US. And this is often forgotten because what it is really good at is heat, not so much electricity. And then the third part is carbon capture and storage, which we know about, basically purifying the flue gas from combustion. So you put those three together, that is BECCS. So how the process works to generate negative carbon emissions is basically tree grows, pulls CO2 out of the atmosphere. That CO2 could have been from an airliner, it could be from rail, it could be truck, it could be industrial emitters, whatever. The key thing is that it's a shared atmosphere, which means that CO2 could, for accounting purposes, could have come from anywhere in the world. And that's really important for what I'll get into in terms of the product. So tree grows, pulls CO2 out of the atmosphere, creates that wood. That's what it is. What is a tree? It's essentially stored solar energy, carbon dioxide from the atmosphere and water from the ground. That's what it is chemically. Then we take that wood, we create energy, release that solar energy, and that generates heat. and we can generate heat and power, etc. But then instead of letting the CO2 go back up, we put the CO2 permanently underground. And if you think about that chain, the CO2 removal from the atmosphere going into, permanently stored 2 kilometers below the surface of the Earth, that means that we're permanently removing carbon from the atmosphere. And that creates a product called a carbon dioxide removal. And this is a very rapidly growing industry. So this is an industry that I believe that Alberta can and should dominate globally. We've got a number of reasons for that, and I'll get into why that is. But just to highlight that there's quite a few projects that are under construction, have signed long-term offtakes for these carbon dioxide removals. There's some examples from the Nordic countries. So the biomass plants that heat Stockholm and Copenhagen. Most people don't know that those cities are actually heated with wood. And then a waste energy plant in Oslo. But then in North America, there's a big push on this in the southern US. And this is why I say Alberta can actually outcompete the southern US, which is the other real place in the world where you can have very low cost permanent carbon dioxide removals using BECCS. So we hear a lot about using biomass and biological materials to substitute, to produce, what the federal government calls clean fuels. Right. The important thing when we talk about how best to use these biological materials is what is the carbon efficiency and what is the cost efficiency. The reality is that if we can take wood and we can turn it to anything that we produce from oil and gas. So this chemicals, except solid products, etc. The key thing is that wood is essentially carbon, oxygen, and hydrogen. And if you take out the oxygen, you're left with carbon and hydrogen, which is essentially fossil fuels, right? So chemically, we can get there. The question is not whether we could, but whether we should. And when we compare BECCS to other uses of that wood, when we talk about an Alberta context, taking this pathway where you're generating heat and power and a carbon dioxide removal, you get 6 times the greenhouse gas reduction per ton of wood as taking that same ton of wood and converting it into, say, sustainable aviation fuel. And this is really important when we think about how Alberta can most efficiently get its resources to market to meet not only energy needs, but also desires from customers of a lower carbon solution. This is just to give you an example. This is sustainable aviation fuel. It compares, sustainable aviation fuel is not zero carbon on a life cycle basis. Some fuels are 60% reduction, 70% reduction, 80% reduction. But in every type of fuel that we switch to, there's a few out there, but in general, every type of fuel we switch to, there is a cost. And that cost can be calculated in the dollars per ton of CO2. Sometimes it's really clear, as in, we had carbon pricing in Canada. So there's a clear thing, but then some of the other requirements, you need to blend this amount of fuel. You need to do this. You need to do that. That all has a cost that we can work out in dollars per ton of CO2. And so when we look at the sustainable aviation fuels that are out there, the most common one currently is, cost between $500 and $1,000 a ton of CO2 to blend that fuel. So you hear Air Canada and a lot of the airlines talk about blending to SAF, sustainable aviation fuel. Well, when you work it out on how much greenhouse gas emissions they're saving per ton, what does it cost per ton? It's $500 to $1,000 a ton. Other types of technologies, if you're using wood, typically we're talking between $750 and $1,250 a ton of CO2. And then you might have heard of ESAF. So this is where you're using hydrogen and you're combining with carbon dioxide. That's looking between $1,000 and $2,000 per ton of CO2. And the reality is there is a limit to how much people, customers, etc., are willing to pay per ton of CO2. This is where BECCS is. And this is why I'm arguing that this is the pathway that we should use, which essentially means we continue using, in this case, Jet A1, kerosene for flying aviation, no change in the actual fuel consumed by the airplane, but we remove those emissions after the fact. And that is actually the much lower cost approach. So putting in real life and why this matters is if you're looking, I'm currently living on the East Coast. Obviously, I actually do a lot of work in Alberta and quite a bit on the West Coast as well. So I unfortunately have to take this flight a lot. But if you're looking at a Halifax to Vancouver flight, if you're looking BECCS, you're adding about 12% to assuming a $900 economy fare round trip. You're adding about 12%. I think that's somewhat, there's more variability in ticket pricing than that. If you're using these other types of fuels, you're looking at a 50 to 100% increase in the cost of the flight. And what that tells me is, number one, people won't pay it, which means, number two, airlines won't actually blend to levels that are meaningful in terms of reducing greenhouse gas emissions. So it has to be on a cost efficient, it has to be carbon efficient. Now, why does BECCS matter? So what we do when we create, is we have this carbon dioxide removal. This is not an offset. This is, hey, I'm not going to cut down my forest if you pay me, those types of things. This is a permanent measured carbon dioxide removal from the atmosphere that goes 2 kilometers below the surface of the Earth and is there forever, right? Or at least the next 10,000 years. And I don't think anybody on this call is worried about anything beyond that. The reality is, and why I say that this is where Canada, and specifically Alberta and Western Canada, this is where the focus should be. In the world, we have about 52, 54 billion tons of CO2 equivalent greenhouse gas emissions. For half those emissions, it is relatively affordable to avoid the emission. We can fuel switch, we can switch to electricity, we can do those types of things. Those are on this graph. This is from Goldman Sachs. On the left-hand side, those are less than $150 a ton US. On the right-hand side are all the other emissions, and that's about 50% emissions in the world. And the reality is, for a lot of these, it's just too expensive, or we don't even have a technological pathway to avoid them. And this is where carbon dioxide removal occurs, or is necessary. And whereas by far the lowest cost approach when we're doing BECCS in Western Canada, and specifically in Alberta, to remove that emission. So it's about taking a pragmatic approach of how do you accomplish these goals. For some emissions, yes, avoiding the emission is the way to do it. But for half the emissions in the world, it is better for the world to come to Alberta to buy a carbon dioxide removal and to continue business as usual from an operational perspective. So I'll quickly go through, I promised a little bit on Canada's forests. The reality is many people are, I don't think most people in the call are in the forestry sector, but our timber harvest in Canada is about 40% below where it was in 2004. Largely that is the result of closure of pulp and paper mills. At the same time, our net greenhouse gas emissions from the forest have been rapidly increasing, right? So that's obviously counterintuitive. Cut less, but, significant increase in greenhouse gas emissions. Obviously, the reason for that is wildfires. And so if we look at wildfires, so this has been a general trend. 2023, though, blew previous examples out of the water. Here's a stat for people in Alberta, is that in 2023, the greenhouse gas emissions from Canada's wildfires was 75% more than the oil sands for the entire history of the oil sands. Okay, so in Canada, we're focusing on the wrong thing. Oil and gas cap, all this type of stuff, forgets about where our largest source of emissions is, which is actually our forests, right? Which are 94% owned by government, right? This is what it looks like. I don't need to tell you about smoky summers in Alberta. Does it have to be this way? That's the question. So the answer is no. There's a number of boreal countries, so we're one of them. There's Alaska, there's Russia, and then there's the Nordic countries. We have in Canada 50 times the wildfire rate per forested hectare as Sweden, 50 times. There's some, geoclimatic differences, but it's not 50 times difference. In 2023, 500 times the wildfire rate. So this is really critical to understand that the Nordic countries of namely Sweden, Finland, do not have the wildfire situation that we do, but in the 1800s, they actually had a higher wildfire rate than we did. Okay? What are they doing? They are actually, counterintuitively, harvesting 7 times the volume per forested hectare that we do in Canada. And you say, well, how can that possibly be sustainable? The reality is in Canada, we harvest less than 4% of the annual growth on any given year. And so Sweden, which harvests 7 times that volume, it's still less than 30% of the annual growth, right? Every year, Sweden is increasing the amount of carbon stored in its forests. It's harvesting a lot more, but it's storing the amount stored in, carbon stored in the forests, in addition to the amount stored in solid wood products, Whereas in Canada, we've lost about 7 billion tons of carbon from our forests since over the last decade, right? I think the numbers speak for themselves. If we manage our forests like Sweden, we would and use that wood for BECCS, we would actually have a a carbon dioxide removal industry of 1 billion tons of CO2 per year. And just to put it in perspective, so that's 1 billion tons. Canada's total emissions are about 700 million. So more than our entire anthropogenic emissions. Okay. As I mentioned, big reason is that we've had why is harvest gone down? Significant decline in the pulp and paper sector. Just as a side note, in newsprint, we are the world's largest exporter of newsprint, but in 2000 we were exporting more than the next 10 countries combined. So this is actually the federal government talks about decarbonization. The decline of the pulp and paper industry, which when you're producing newsprint requires a huge amount of electricity. The primary reason that greenhouse gas emissions have declined in Canada since 2005 is the collapse of the newsprint industry. Right? The reason is because electricity demand declined in Ontario, in New Brunswick, and Nova Scotia, and they had to close coal-fired power plants because demand collapsed. Right? Not what you hear most of the time. So what's it looking like in other countries? So this is Sweden. 40% of the energy consumed in Sweden is bioenergy. They've decarbonized heat and they've decarbonized electricity, and they have a higher GDP per capita than we have. Okay. The only thing they have left to decarbonize is transportation. And I would argue BECCS is by far the lowest cost way to do that. And they're actually developing BECCS projects under construction currently in Sweden, having recognized this. So bioenergy, this is what it looks like in practice. This is a biomass combined heat and power plant in downtown Stockholm. It heats 190,000 residences. It generates enough electricity for 150,000 EVs, 100% wood chip fired. And then basically that heat is distributed to those 190,000 residents using underground hot water pipes, the heat utility, right? So it is absolutely true that we will never decarbonize building heat in Canada using electricity. This is the proven approach, though, is citywide district heating systems. And shout out to both Edmonton and Calgary, who have recognized that they're not going to electrify the building stock. And the only way to decarbonize buildings is large-scale district heating systems using hot water as the energy carrier. This is where the plant is located. The stack is across the street from residential. You see the plants in the background. They put a wharf in. This is 40% rail delivery, 60% marine. This is what it actually takes to decarbonize, not writing checks for heat pumps. Okay. Just to show you, this creates rural jobs. You bring rural forested, in some cases, agricultural communities on board with your, urban-driven climate action. Right. Copenhagen, not a Denmark, not a country with a whole lot of trees. But this is what they decided. This was commissioned in 2019. Again, 100% wood chips, 1.2 million tons per year. And this plant alone reduced greenhouse gas emissions by 1 million tons. Again, you see the plant in the middle, the plant on the right there, that's a waste energy plant that you can actually ski on. Again, over 99% of buildings in Copenhagen are connected to the city-owned district heating system. You're not allowed to have your own furnace or boiler in Copenhagen. But you know what? People don't want explosive gas coming to their house when they can just get hot water, right? For space heating and domestic hot water. Unlimited showers, no hot water tanks, right? Just to put the scale in perspective of what, the scale of the forest sector operates at, this is a new pulp mill in Finland. The scale of this in terms of wood going into this pulp mill, this would generate 7 million tons of carbon dioxide removals if you captured all the CO2 from biomass, if all the biomass was used for energy generation. Bioenergy is also well known within the industrial sector. There are some temperature limitations, so you can't do certain things like you can't do an ethane cracker using biomass as the heat source. But for a lot of manufacturing, we can use bioenergy. And that's why if you look at Europe, 90% of renewable heat is in the form of biomass. So, and why does that matter? Because 2/3 of our energy consumption in Canada is heat. right? We spend a lot of time talking about electricity, but it's only 17% of our energy consumption, and only 12% of our energy consumption actually requires electricity. In Alberta, it's even more extreme, right? In Alberta, electricity represents only 8% of energy consumption. 8. So that means you're not going to electrify all the thermal loads, right? Over 80% of the energy consumption in Alberta is for heat. Okay? Carbon capture and storage, I'm not going to go through this, but just to point out that we already have a very large biogenic, so this is the biomass combustion CO2 emissions in Canada. These don't show up on large emission inventories because it's biogenic, it's not a liability. But when we look at the actual stack CO2 emissions, there's more CO2 emissions from the forest product sector than refining, chemicals, steel, and cement combined. The only one that's higher is oil sands. And Alberta already has 9 million tons of this, right? To show you the extent of why Alberta is, should be the leader, I'll show you what the Europeans are doing, because all their CO2 storage is in the North Sea. So they've put together something called the Northern Lights. And so this is Shell, Equinor, and Total. It's about $2.5 billion joint venture. And what it is CO2 transport and storage as a service. And so what they have essentially is, emitter facilities have capture, but then you have liquefied CO2 carriers, ships, coming to pick up that CO2, transport it to a CO2 receiving terminal in Norway, 120-kilometer offshore pipeline, 2 kilometers below the seabed. You can think about the costs associated with that type of infrastructure and how much lower cost it is to develop the same carbon dioxide removals in Alberta. This is what it looks like: shipping, CO2 receiving, offshore pipeline, below the subsurface. On the left is the computer rendered images. On the right is the actual infrastructure. So this is the CO2 receiving terminal has actually been already commissioned. Liquefied CO2 carriers, just like a liquefied, natural gas carrier, right? LNG carrier. The one on the right is, they've already received the ship for the carrier from China, and it's already in Norway, Norwegian waters. Okay, so there's already been 7 contracts signed to provide this service, if you will, and of those, 6 are biogenic CO2, and that's for a reason. It's because when you capture CO2 from a fossil fuel source, all you're trying to do is eliminate a liability, right? The government establishes a price, and you're trying to eliminate that liability. When you capture and store the CO2 that's biogenic, what you're doing is you're taking a non-liability and creating a new product. Totally different thing, and that product is global. So I don't have much time left, but I'll just say why Alberta. Alberta is, there's a couple things. One is onshore, low-cost storage, but a key thing here is that it is publicly owned pore space, and also the forest asset is publicly owned. It is like a carbon moving service for the provincial government, right? Because it's their carbon. And when I try to do a BECCS project in Alberta, I have one contract to sign with the pore space owner, the provincial government. If I go into Texas or Louisiana, that's private land. And so, and therefore, I have to get everybody that is possibly impacted signed on. And that is extremely different because the CO2 plume spreads, right? So, in terms of cost, this is not free without a doubt. But as I said, if you compare to alternatives out there, this is actually affordable. You can bundle it, right? You can bundle it with LNG, you can bundle it with crude, depending upon what the customer wants to pay. We can deliver low-cost fossil fuels or low-carbon fossil fuels, and in some cases, if they want to pay for it, zero life cycle carbon, fossil fuels. So whether it's LNG or whether it's crude that's used for gasoline or even the diesel or gasoline itself, we can make it net zero on a life cycle basis by bundling carbon dioxide removals with that product. This really puts the onus on the customer, not the producer per se, right? This is just an example applying CDRs to LNG product. To put the scale in perspective, right? If we're talking about LNG Canada, the amount of gas from LNG Canada with both phases would eventually be about 230 terawatt hours of electricity generation going through a combined cycle plant, right? To make that net zero on a life cycle basis, basically we need to just bring timber harvest back up to where it was in 2004, prior to people going digital, right? You probably think about how many newspapers you used to have stacked outside your house for pickup at the end of the week, right? But when we put that in scale, that 230 terawatt hours from phase 1 and 2 of LNG Canada, that's equal to 37% of Canada's electricity generation, or 45 site seats. Okay. This is decarbonization at scale, and it relies on us working with our forests, our publicly owned forests, avoiding wildfires through active management, reducing risk, and to actually deliver on customer expectations. So I'm not going to go through everything here because I know I'm running out of time, but even the IPCC, the International Governmental Panel on Climate Change, says we need between 10 and 20, but by 2050, between 5 and 10 billion tons of BECCS carbon dioxide removals to meet climate goals. If we can't do a couple 100 million in Alberta, I don't see how that's possible, because Alberta is the best place to do this. And then finally, the Canada Energy Regulator says you cannot get to net zero without BECCS. And the key thing here is, what is the number one source of electricity in the prairies under a net zero scenario? It's actually biopower, which is not because it's lower cost than wind or solar to generate electricity on a kilowatt hour basis. It is because you have a co-product with BECCS, right? You have that carbon dioxide removal. And as the value of the carbon dioxide removal goes up, the net cost of the energy goes down, to the point of what they modeled in a net zero scenario is the energy itself becomes negative cost generation option. In other words, it outbids everything else on the grid, and that we have lower energy costs in Alberta, in other prairie provinces, because they're essentially subsidized through the sale internationally of carbon dioxide removals. We're not the only ones doing this, right? There's significant progress, and there's plants under construction. There's some that have actually been fully commissioned at waste energy plants. And so, this is really the direction the world is going. The EU has a carbon removals framework where we need to align our regulations so that we can sell our carbon dioxide removals into the European trading system, so that they can use it for so that companies can use it for compliance, and that we have a new market for these carbon dioxide removals. So we're doing, as Catherine mentioned, we are developing Canada's first BECCS project. It's basically adding carbon capture and storage to a pulp mill, 1.5 million tons of carbon dioxide removals per year. And we're fortunate to have funding from Natural Resources Canada and Emissions Reduction Alberta to do the $15 million FEED study. So I'll leave it there. I know I went a bit over, but hopefully it was useful, and I got you thinking a little bit differently about how we can actually economically benefit from the energy transition. I'm a proud Canadian. I've lived coast to coast. I grew up in Saskatchewan. And I really want to. I think this is something where we can. People don't need to be so polarized, and we can come together and really deliver on the global climate goals, but do so in a way that's profitable for us. Thank you very much.
Well done, Jamie. Thank you.